Hi there, my name is Steven and my partner's name is Jarvis, and this is our entry for the MATLAB programming contest. Our main inspiration was after we learned about the various functions for generating randomized numbers and the use of switch statements to determine different results. So with these two ideas in mind, we decided to move towards a casino type framework for our game. So we decided to make our program in stages and gradually add to it as we got through each assignment. The initial stage was a simple game found in many casinos, this being blackjack. Blackjack was an obvious choice as the concept was straightforward. A randomizer would generate cards, and the values of the card would be matched against the dealer, and we would determine an outcome. We then moved towards a game that employed similar concepts, but a different way, this game being roulette, which my partner will get into. The final stage of the casino was a sort of hub or entrance to the casino that gave a more clear selection screen. This was done using commands learned in the last assignment actually, mainly the use of list_dlg and its following commands. In this sense, the box that pops up serves as a greeter at the entrance of the casino, while the command window itself serves as a table or apparatus in which a game is played on. So the entrance screen is divided into two main parts, the money system and the selection screen. The selection screen simply is an option box that allows the player to first decide how much money they would like to start with, and then they can choose which game they would like to play. It's quite simple by design and makes use of a while loop to allow the player to play the games again and again until they choose to quit. The money system is also quite unique as it contains a persistent variable total that defines how much remaining money the player has over the course of the games. The entire structure of the code is built upon the money system, as the games themselves are designed to be functions that serve to edit the money variable over the course of the game. The money system is also unique in the fact that it will persist even when games are reset, so the player can have a running total of their current balance across however many games they want to play. As the code allows the player to choose how much money they want to come in with, the result of winning can be defined by the player themselves. So if we want to go through this, first it prompts you for how much money you will want to bring, and then it lets you choose which game you would want to play. So when you're done playing the games, it'll tell you your final balance, and you can decide if you won or not.
At the heart of blackjack, there is this function, the deck shuffle function. And what it does is that it outputs shuffled decks of cards. It all starts with this file, carddeck.dat. It's just a list of all the cards that we have. What the function first does is that it imports this list of cards into the function. That's what this first half does. And then to shuffle all the cards, we create an empty row vector with spots for all the cards. Then for each card, we pick a random spot in the deck and then place the card in there and then set that position as not empty. This can be repeated through many decks of cards, so this creates the effect of allowing multiple decks to be shuffled within each other.
So our blackjack game is separated into four main phases: the betting phase, player phase, dealer phase, and end phase. The phase names are explanatory of the stages of how blackjack is played, which can be found in the README file. The main outline of the function uses the card system to track hand values for the dealer and player. Using multiple if statements to check the player's hand, the code can tell if the player's hand has busted or if they may choose to pick up another card. After the player is okay with their hand, the code then begins drawing for the dealer, which leads to three scenarios which are represented as switch cases. Assuming the if statement of the player's hand being bust is not on, the code will then compare the player's hand to the dealer's hand and lead to an outcome of winning, losing, or a tie. By making effective use of if and switch statements, all scenarios of the game can be covered, after which the player can choose to play again or possibly quit and play another game. So if we go back to the code here and choose blackjack, it'll prompt us for how many decks you want to play, and then how much you want to bet in that certain round. In this case, the total is 15 and we'd like to get another card. In this case, we have busted and lost. It'll then prompt us to play another round of blackjack, and if we do not want to, we can leave and we can try to play another games, such as roulette, which my partner will get into.
The roulette game mainly operates with three subfunctions. First is roulette bet, which lets the player input whatever bets they would like to make on the roulette wheel. Roulette spin will then simulate a roulette wheel spinning, adding a bit of flair with some pause and random commands. And finally, roulette pay will take the number and the list of bets and will pay accordingly if there's anything that's successful.
And that is the code to the game we created. We hope it is as entertaining as it is informative. All images were royalty-free stock photos found on Google, and the last slide lists where we found them. So thank you for your time.